Okay, so very briefly in this video, I'm going to go over how to convert between standard form quadratics and vertex form. Obviously, by completing the square, I've already made a number of videos about completing the square already, but anyway, we seem to have a hard time with it. So uh, here we're going to get some more practice with it. So let's say we have a standard form quadratic. So f of x equals I don't know, 2x squared plus 8x plus 3. So that is a standard form quadratic, right? And I want to convert this into vertex form, of course, to where it looks like this instead. Okay, so we're already familiar between the two forms. We're just now learning about vertex form and what it all means. But we know algebra well enough, and we should know how to complete the square well enough to convert between these two. So first, what I'm going to want to do, obviously, is complete the square. Well, as is, we cannot complete the square whenever a is equal to anything but 1, right? Because when we complete the square, we're assuming we're doing it out of this form, x squared plus bx, right? But here we have 2x squared plus bx, okay? And we need it to be just equal to 1x squared. Okay, so that we can plug into our little formula that we have for this. Um, it's pretty simple to follow. Okay, so I need to factor out this a term, this 2, and that's exactly what I'm going to do first. Okay, so I factor out the 2. That means it's sitting outside of some parentheses. I factored it out from here and from here. Okay, so that means I'm left with just x squared plus 4x. And then, of course, I still have the plus 3 sitting off to the side over here. Right, so the 2 and the 3 are both waiting to be used again here in a second after I complete the square. Now I have it in the form that I needed to be in, x squared plus bx, in this case, x squared plus 4x. Okay, so I'm going to complete the square with what I have there. Okay, so b is obviously 4, half of b is 2. So I have x plus 2 all squared minus, well, we need half of b itself squared, so minus 4. Okay, and then I can't forget that I still have this 2 sitting out here and this 3 plus 3 sitting out there. Okay, I'm not finished yet. What I need to do next is redistribute what I factored out back into these parentheses. Okay, so this is going to become 2 times x plus 2 all squared. And then, of course, 2 times negative 4, well, that's going to give me a minus 8. And then I still have this plus 3 sitting here. And 2 times x plus 2 all squared minus 5 after I combine like terms. So this is what I've got. Okay, and this tells me what my graph more or less is going to look like a little bit more specifically than what I can see in standard form. Okay, that said, my vertex, of course, would be at negative 2 by negative 5. It'd be here. I'm opening upwards because my a term is positive. And I mean, that's really all there is to it. Okay, so let's do one more example just for the sake of this video. Okay, and let's say that there was not an a term. Okay, so that seems to mess us up just as badly as if there was one. Let's say it was negative x squared plus 6x. Heck, let's do an ugly number. Let's say 3x minus 10. And again, we're going to look to complete the square with our x squared plus bx, but we do still have a sort of a problem here, right? We need to factor out that negative, so I factor out the negative. That leaves me with x squared minus 3x now. And of course, I still have the minus 10 sitting out there waiting. Okay, so now I'm going to complete the square with what's inside. So that's going to become x minus 3 over 2 all squared minus 9 over 4, right? And I still have the negative sitting out there waiting to be distributed back in, which is exactly what I'm going to do. So that leaves me with negative x times, or x minus 3, well, x minus 3 over 2 all squared plus 9 over 4. Okay, and then minus uh, 40 over 4, because that's what that 10 would become. Right, this minus 10 became negative 40 over 4. Then I just combine like terms. And now I have got negative 31 over 4. Right, and there you have it. A times x minus h all squared plus k. And of course, my graph is going to open downwards now because my a is negative 1 this time. I'm shifted to the right by 1.5, so we'll say 1.5 is there. Negative 31 over 4, that would be 7.75. So negative 7.75. Way down here, we'll say negative 7.75. Okay, so that's where my vertex is at, and I would be opening downwards. Okay, so that's all I'm going to do for this video. Again, all we're doing is completing the square, something that we've done a million times over. We just have to be careful about this step here where we redistribute whatever it is we factored out so that we could just, have 1x squared plus bx instead of, negative 1 or 2 or something like that. Okay, like always, shoot me an email if you need anything. Otherwise, goodbye.